Welcome back to another chemistry session. Today we shall be dwelling strictly on naming of organic compounds, and we shall be combining hydrocarbons with other organic compounds. So we want to learn naming of organic compounds. Before you are examples to name, you have to name the following. So the first thing you look at the functional group here. In example 1 we have single bond all true. So that means it belongs to the homologous series alkane, and the handling name is going to be hene. The handling name is going to be hene. Then you determine your longest chain. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So the longest chain is 3. And 3 carbon is what? That's prop. That's propane. Propane. That's prop. So that means carbon 1, carbon 2, carbon 3. Let's use the straight one. For that is convenient. So CH3 here, CH3 here, they are substituents and they are the same. So the name of the CH3 is methyl. Methyl. That CH3 is attached to carbon what? Carbon 1, carbon 2, carbon 3, that's carbon 2. If you name from the back, it falls on carbon 2. If you name from the front, it falls on carbon 2. So that means it is attached to carbon 2. And how many methyl do we have? We have 2. That will be di. Both are attached to carbon 2, that is 2, 2 dimethyl propane. So the name of the compound is 2, 2 dimethyl propane. 2, 2 dimethyl propane. That's the name of the compound. Look at it keenly while we name the other compounds. I want to believe you understand that. Okay, example 2. If you look at example 2 also, it has single bond all true. So the ending is going to be ane. How many carbon do we have? 1, 2. We have 2 carbon. So 2 carbon is X, as we learned in the other class. So that is ethane. That is ethane. And we have substituents chlorine attached to it. Don't forget that when you have chlorine as a substituent, you name it as chloro. It is named as chloro. That's chloroethane. And your chloro is attached to what carbon? Carbon 1, carbon 2. If you number from the front, that will be carbon 1, carbon 2. But if you number from the back, that will be carbon 1, carbon 2. Don't forget that lower number is preferable. So we number it as carbon 1, carbon 2. And we have how many chlorine attached? We have 3. 1, 2, 3. That will be trichloroethane. And the 3 chlorine are attached to only 1 carbon. So that will be 1, 1, 1 trichloroethane. 1, 1 trichloroethane, because the 3 chlorine are attached to carbon 1. I believe you understand that. While we name the third compound, we want to name the third compound. If you look at this compound, that compound, you will see that we have the functional group OH. The functional group OH. So that means the ending name of that carbon, the ending name of that carbon is going to be hol. Will be hol. Hol, because it belongs to the homologous alkanol. So your hol is attached to which carbon? If you number from the back, that will be carbon 2. 1, 2. But if you number from the front, that will be carbon 3. 1, 2, 3. Don't forget, lower number is preferable. So that will be 2. Your all is attached to carbon 2. Then you determine your longest chain. Reminder, you are to name from the back as you learned in the previous class. So your longest chain, 1, 2, 3, 4. 4 carbon is boots. So that will be butan 2 all. That's butan 2 all, which we call butanol. But because the all is attached to carbon 2, that's why we show the position butan 2 all. So there's no substituent attached to it again. So the name of this compound is butan 2 all. Butan 2 all. Number 4, we have OH as well as the functional group. So the ending name is going to be all. Your OH is attached to which carbon? Count from the front. 1, 2, 3, 4. It will be carbon 4. But from the back, it will be carbon 3. 1, 2, 3. So carbon 3 is preferable. So that means it is attached to carbon 3. The next thing is to determine your longest chain. Determine your longest chain. 1, 2, 3, 4, 5, 6. That's 6 carbon. 1, 2, 3. That's 3. 1, 2, 3, 4, 5, 6. That's 6 carbon. Since we have 2 6 carbon, choose the straight one for convenience. That means CH3 here will be a substituent. And the name of this CH3 is methyl. Alright. Don't forget that it has 1 carbon. That's why it is met. But the reason why it is methyl is because it is 1 hydrogen lesser than alkane. Methane is CH4, while methyl is CH3. So take note of that. Alkyl, it is 1 hydrogen lesser than alkane. So your longest chain is hexanol. Okay. Then we have the substituent methyl. The methyl is attached to which carbon? 1, 2, 3, 4, 5. Carbon 5. So the name of the compound is 5-methyl hexantriol. 5-methyl hexantriol. Let's consider some examples further. Stay tuned. Alright, these are some other examples for us to name. Example 5. If you look at example 5, we have single bond all true. We have single bond all true. So that means the ending name for this is going to be A. The ending name is A. Then you determine your number of carbon. 1, 2, 3, 4. That's 4 carbon. That's butane. Boots. 4 carbon is boots. And then you see we have substituents. 1, 2, 3. Which are chlorine. We have substituent chlorine attached to it. So that's going to be chloro. How many chloro do we have? 3. That will be trichloro. Then your chloro are attached to which carbon? If you number from the front, that will be carbon 1, 2, 3, 4. So that means we have 1, 2, and 4. But if you number from the back, it is going to be carbon 1, carbon 2, carbon 3, carbon 4. That will be 1, 3, 4. Since it is the lower number that is preferable, we go for 1, 2, 4. Because 1, 2, 4 is lower than 1, 3, 4. So that means it's going to be 1, 2, 4 trichlorobutane. So the name of the compound is 1, 2, 4 trichlorobutane. Example 6. We have a benzene ring. This ring is a benzene ring. But whenever we have, this is benzene ring, or you have it this way. Benzene ring can be like this. So the two represent benzene ring. But anytime you have OH attached to benzene ring, it is no longer called benzene, it is called phenol. It will be called phenol. So if you are to now name this now, this is going to be carbon 1, carbon 2, carbon 3, carbon 4. So those edges are where you have carbon. So that means this NO2 is a substituent. And don't forget that the NO2, whenever it is a substituent, it is named as nitro. Therefore, the ending name is phenol. And the substance is nitro. Your nitro is attached to which carbon? Carbon 4. So the name of the compound is 4-nitrophenol. 4-nitrophenol. So I believe that is taken 4-nitrophenol. Alright, as we proceed, we are going to name compound number 7. This is benzene ring. So that benzene ring, we have functional group for alkanoic acid, COOH attached. We also have functional group for alkanol, OH attached. Don't forget that in order of priority, COOH is more important than OH, is greater than OH. So when you have functional group of alkanoic acid attached to benzene ring, the name will be called benzoic acid. Benzoic acid. So that means your OH will be treated as substituent. And when you treat OH as substituent, what do you call it? Hydroxy. It is called hydroxy. That's what we learned in the last class. The OH will be called hydroxy. So to which carbon is the hydroxy attached? This is carbon 1 here, this is carbon 2. So your hydroxy is attached to carbon 2. So that means the name of the compound is 2-hydroxy benzoic acid. 2-hydroxy benzoic acid. Compound 8. Next name compound 8. So looking at compound 8, we have single bond, all true. That means the ending name will be A. It will be A. So determine your longest chain. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So we have 2, 4 longer chain. Provided you choose the straight one for convenience. So if you choose the straight one, that means this branch is a substituent. This branch is CH3 and the name is methyl. So since you have 4 carbon, 1, 2, 3, 4. 4 carbon is what? That's butane. That's butane. Alright, butane. That's 4 carbon. Then you have substituents. Bromo. You have bromo as a substituent. You have methyl as a substituent. Bromo as a substituent. And methyl as a substituent. In alphabetical order, this is methyl. In alphabetical order, bromo becomes first, while methyl comes behind bromo. Alright, so your bromo is attached to which carbon? Carbon 1. While your methyl will be attached to carbon 3. If you number from the back, that will be carbon 1, carbon 2, carbon 1, carbon 2, carbon 3. So that means we have 1 and 3. But if you number from the front, carbon 1, carbon 2, carbon 3, carbon 4. That means we have 2, 4. If you compare the two, 1, 3 and 2, 4, you see that 1, 3 is lower than 2, 4. Therefore, we make use of 1, 3. And so, you put your methyl here, methyl. Your methyl is attached to carbon what? Carbon 3. And then your bromo, you come to the front. Your bromo is attached to which carbon? Bromo. Your bromo is attached to carbon 1. So the name of the compound is 1-bromo-3-methyl butane. Alright. The name of the compound is 1-bromo-3-methyl butane. 1-bromo-3-methyl butane. That's the name of the compound. Let's consider some examples further. Stay tuned. Alright. We still want to consider some example further. I want to believe with this you should have no problem in naming organic compounds. Look at this, number 9. We have COH functional group and we have CN functional group. COH for alkanoic, CN for haloalkane, otherwise called halide. But COH is greater than CN, which is chloroalkane, in order of priority. That means the ending name of this compound is going to be oic acid. Oic acid. Alright. How many carbon? 1, 2, 3, 4, 5. 5 carbon is pentan. That's pentanoic acid. Pentanoic acid. Okay, you have a substituent ClCl. That is chloro. Chloro. How many chloro do you have? That's 2. Chloro. Since you have 2 chloro, that will be dichloro. And they attach to carbon what? This will take the lower number. 1, 2. So they attach to carbon 2. 2 dichloro-pentanoic acid. 2 this is carbon 1 and this is carbon 2. 2 dichloro-pentanoic acid. Example 10. We have triple bond and single bond. Triple bond is more important than single bond. And so the ending name will be ene. The ending name will be ene. That's alkyne. Your ene is attached to each carbon. If you number from the back, 1, 2, 3. But if you number from the front, it will be carbon 1, carbon 2. If you number from the back, carbon 1, carbon 2, carbon 3. So you have to use the lower number, which is 2. So that's going to be 2 ene. 2 ene. What is the longest chain? 1, 2, 3, 4, 5. 5. So 5 is pent. Pent 2 ene. Pentane. Pentane. So the name of this compound is pent 2 ene, which we know as pentane. Example 11. You have single bond all true. Single bond all true. So the ending name is going to be ane. The ending name will be ane. Then you determine your longest chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have 6 occurring 3 times. So for convenience, choose the straight one. So that means you have 6 carbon. 6 carbon is hexane, X, hexane. In that case, that means CH3 here, C1, 2, 3, CH3 is methyl and is a substituent. Also, C2, 1, 2, 2 carbon and H5. This is C2, H5. This one is CH3. So you have 2 carbon, 1, 2, 5 again, 1, 2, 3, 4, 5. C2H5, the name is ethyl. Et is 2 carbon. So that is ethyl. So if you look at it, if you number from the back, this will be carbon 1, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So if you name from the back, your methyl is attached to carbon 2 and your ethyl is attached to carbon 4. But if you number from the front, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. You are going to have 2, your ethyl is attached to carbon 3, while your methyl is attached to carbon 5. You have 3, 5. So between 2, 4 and 3, 5, which one is slower? 2, 4 is slower. So you are going to use 2, 4. In that case, alphabetical order, ethyl will be at the front, while methyl will be at the back. Methyl will be at the back. Methyl. Your methyl is attached to which carbon? It is attached to carbon 2. Carbon